KPA members, other invitees and students to this online webinar series. So we have been conducting these talks for the past 2 years almost on a variety of topics, from the micro world to the macro world, from quarks all the way to cosmology. So our main intention is to encourage or inform our teachers and students about different branches of physics and allied subjects, so that that will help them in their teaching as well as research. So these are somewhat review talks for lasting over for 1 hour, approximately 1 hour review talks given by faculty members from colleges, universities, and research institutes. And sometimes we have conducted these talks in Kannada also, with the view of encouraging the usage of Kannada in higher education, so that our people, students, feel at ease. It is a very convenient way of communication, or the most efficient way in some sense. So there are problems in implementing the medium of instruction at the higher levels, but we have to make an attempt. And this is probably one of the around the 80th talk in the series. And today's talk. So today's talk will be delivered by Dr. Revanasiddappa from PES University. So he will speak about biosensors. So this is an interdisciplinary subject which will be useful to engineers, scientists, chemists, and physicists, and so on. So before he will speak for about 15 minutes, followed by 10 minutes of question answer session. And since he knows Kannada, you can also interact with him in Kannada. There's no formality. What is important is the ease of communication, or the efficient communication is more important. So before I request him to speak, I request our Joint Secretary, Dr. Rudaswamy, to just briefly introduce the speaker. Over to you, Dr. Rudaswamy.
So thank you very much, sir, for this great opportunity. It is indeed a great honor and immense pleasure for me to introduce today's eminent speaker, Professor Dr. Revanasiddappa M. I am proud to say that Dr. Revanasiddappa completed his master degree in chemistry, securing first rank and gold medal, MPhil degree and PhD degrees, all from Gulbarga University. Presently serving as Professor of Chemistry in PES University, Electronic City Campus, Bangalore. Life members for International Association of Engineers, Indian Society for Technical Education, and Indian Council of Chemistry. Secured awards of RULA, International Research Ratna, Excellence in Research by CSI College of Engineering, Ooty, Abhivakti Project and Chemistry Research Paper presentations, and IAPT National Symposium Best Poster Award. Published 130 research papers in reputed journals, presented 200 papers in national and international conferences, and guided 4 students to get their PhD degree. Participated in social activities such as science awareness for rural students and global warming awareness programs. So with this brief introduction, I now request Professor Revanasiddappa to kindly deliver a talk on types of biosensors. Over to you, sir, and thank you very much, sir.
Thank you, sir. Thank you for giving me giving brief introduction. Good morning, everyone. I'll start with the sensor and biosensor. What are the important applications? What is the specificity of all these things, and selectivity and other aspects will be discussed, followed by I'm taking one of the important, that is glucose sensor. I'm discussing elaboratively construction, working principle, and limitations of the device. So I'll start with biosensor now. Okay. So the biosensor is one where we're going to use analyte sample is the biosensor, maybe a blood, maybe any other fluid sample in our body. So it is called it as biosensor. The father of this biosensor is the Leyland C. Clark invented the Clark oxygen electrode. It's a pivotal device that allows real-time monitoring of patients' blood oxygen level and has made surgery safer and more successful for millions around the world. So all these devices are very, very important nowadays because everybody wants smartness. We want a smart mobile phone, smart watch, smart kitchen, smart home. In this condition, whole world behind the sensor application and manufacturing and innovations of new material in this direction. So biosensor is an analytical device which is containing immobilized biological materials, maybe enzyme, antibodies, nucleic acid, hormones, organelle, etc., which can specifically interact with an analyte and produce physical, chemical, or electrical signal that can be measured. Analyte the compound which we are going to analyze, maybe glucose, urea, drug, pesticides, any other contaminants present in the analyte sample. So biosensor basically involve the quantitative analysis of various substances by converting their biological action into measurable signal. So then what is sensor? I am always saying our body is itself is a wonderful sensor. So there is quick response. In microsecond, it will respond in our body. So what is that sensing mechanism? In our body, something is touching on our skin, something is there, or maybe cold object, maybe hot object, or light radiation fall on our skin. Immediately it sends. So detection time is very less and so fast and immediately respond. No doubt, our body is itself is wonderful sensor. Then how we brought this into the external world by using different materials and how it is mimicking our body. So first of all, what is sensor? Sensor is a device that detect and respond to some type of input from the physical environment. What is this physical environment? Maybe input may be light, maybe heat, or motion, or moisture, pressure, or any molecule or any substance such as analytes. So here I have given one simple schematic representation. In our body, what happened? Something is touching on our skin. That is, there is a sensory receptors already there under the skin. That is nothing but there is a in and around presence of calcium and potassium ions. And these ions connected to the sensory nerves and which is directly connected to the brain. So in the brain, it is going to decide whether it is the different object, maybe a cold or maybe a light, anything. It can detect immediately. So that is what brain is processing in our body. Similarly, in place of our brain, we are going to use a computer. What we are going to do? There is sensing element is called receptor. Take example. So carbon dioxide is the pollutant in the atmosphere. One of the chemical molecule is there that is called tin oxide. Tin oxide and carbon dioxide will go and absorb. There is a change in the electric signal. What is the change in the electric signal? Either it may change in the resistance or change in the conductivity or change in the potential at the vicinity of the electrode or on the surface chemical molecule. Then it is called as a transducer. What is this transducer? Transducer is one which can convert one form of energy into another form of energy. The chemical species will go under the and change in the signal, that is resistance or maybe electrical. That signal may be very, very weak and so subtle, not able to detect directly. In this condition, we use one electronic circuit is called analog circuit to amplify the signal. This is called as amplification pre-processing. Then we are injecting into the computer. Already in the computer, we have written the program. What is that program? So whether it is linear relation is there or not. So this is the molecule as increased concentration. This is the millivolt or this is the resistance. This is the optical or optical density. All these things will be calculated before and all these things written program very well. and that is interfaced with a computer with this sensor element. Automatically, when the unknown sample is there, it will calculate, immediately gives the unknown concentration value. In this way, computer works in place of our brain, and it is going to give the information about which type of input it is, whether it is heat or a motion or maybe a pressure or any other thing. This is called as signal processing in living organism and also in the intelligent machine, particularly in the sensor devices. So, what is this biosensor? Biosensor is very simple. So, in place of chemical molecule, we are going to use a biological elements. What are these biological elements? Viruses, bacteria, fungi, protozoa, plants, and animals. No, one day I was referring one of the research paper. I was studying for my research topic. At the time, I read in one of the article, animal cells as the multitask, and whatever the technology we have created, it does only one task. So particularly in the washing machine, they use fuzzy logic. I don't know much, I'm chemist, but I learned from the literature, fuzzy logic technology, where there is a confusion, they are going to use this fuzzy logic system. So why it is so? Animal cells is having the multi-dimensional multitask. For example, I'm talking here. I'm aware of it. I'm going to talk something on biosensor. I'm seeing all these things in and around. I actually am doing multitask. The same thing can't possible with our technology what we have created as of now. So biological elements plays a very important role now. It is going to replace this chemical molecule into the animal cells because it can does multitask. Many researchers are trying to use animal cell in place of chemical molecule. So here, these are the biological elements we are going to use for identifying the type of input in and around to make our device become more smarter. So this is about biosensor. So already I have explained in the biosensor, there is analyte. Analyte is the substance to be analyzed. And there is sensory layer. It is nothing but biological element. And which is attached with a transducer. Transducer may be amperometric or maybe a piezoelectric crystal or any other things. So it is going to sense what kind of analyte it is based on the reaction, based on the interaction. It will be recognized and the same signal is amplifying and giving it to the computer for further processing. So what are the principles are involved in the construction of biosensor? Biosensor is essentially comprised of the following two major parts. One is called as biological component for sensing the presence as well as concentration of analyte. Again, it must be a linear relationship. And transducer, you already explained about transducer. It converts one form of energy into another form of energy. These two are very, very important in the construction of any sensor. Not only biosensor, any sensor, these two are important. So, there are so many types of biosensors are available based on electrochemical biosensor. What is this electrochemical biosensor? We are going to use electrodes. What is this electrode? What is this electrochemistry? Electrochemistry always talking about oxidation as well as reduction reaction. In the redox reaction, we are going to observe the potential difference between the two electrode systems. Accordingly, we have been classified into four types. One is called amperometric biosensor. What is this amperometric biosensor? Here we are going to convert millivolt into current. So through the redox reaction, it is going to produce current. Here we are going to measure current. So it is called as amperometric biosensor because analyte is the one that substance is introduced at the sensory receptor, and where it reacts, during reaction, number of electrons are released that will be converted in the form of current. So this is called as amperometric sensor. The other one is called potentiometric sensor. Potentiometric sensor is very simple. For example, in the atmospheric air, there is no other ingredients, means there is no LPG gas, there is no ammonia. So in this condition, we are placing two electrode system. We hope we all of us observed in the malls, particularly in the big malls, there is a smoke detector. In the normal environment, nothing is burning, nothing is catching fire, and they put one electrochemical sensor. It is nothing but a potentiometric sensor. So the vicinity of the electrode, only air is there. There is no other gaseous molecule. Automatically, the electrode potential difference remains same. When something is burning in the mall, automatically new molecules are released and it disturbs the EMF between two electrode system. That is giving the information to the end user. Automatically will come and rectify the problem. This is what it is called potentiometric sensor. And where we are using the bioelement, so it is called as potentiometric biosensor. And impediometric biosensor, where we are going to use either capacitor or maybe the resistance and inductance coil is used. And we do get in terms of impedance, that is real impedance as well as imaginary impedance. By using this, where we measure either resistance or maybe electrical conductance. With this, one can easily identify. Voltammetric biosensor. Here also voltammetric, there are 3 electrode systems will be there, the same principle. And the other type is called physical biosensor. These are called as piezoelectric biosensor and thermometric biosensor. Piezoelectric, later I will elaborate all these things. Piezoelectric material during interaction, change in the mass, maybe other things. So that can be determined by using piezoelectric material in the construction process. So it is called piezoelectric biosensor. Thermometric biosensor, during interaction, during the reaction, heat energy is released. That heat energy will give the information about what type of analyte it is in the sample or in the analysis. Others may be optical biosensor and variable biosensors. So in this way, we have been classified based on the type of reaction, based on the interaction, based on the light and other input in and around the environment. So this is about classification. So what is this electrochemical biosensor? I've already discussed electrochemical biosensor is one. There are 2 electrodes and output is voltage. That output we are going to measure. Actually, in the amperometric biosensor, where there are 3 electrode system. One is called it as counter electrode. The other one is called it as a reference electrode and the working electrode. At the working electrode, the reaction takes place, and during reaction, the change in the electrode potential, and reference electrode is maintained constant potential, and the counter electrode is minimize the unwanted ions present in the medium. So working electrode is plays a very important role where the reaction takes place, both oxidation as well as reduction reaction. So this is used in the amperometric sensor. Potentiometric, as I have already discussed, there is a change in electrode potential with the help of Nernst equation, simple Nernst equation. One can easily understand oxidizable and reducible species present in the medium. Accordingly, it is going to change the potential. The change in potential is give the information about what type of analyte by using potentiometric sensor. As I have already discussed, this is what we are constructing in the device. Actually, there is one sensor, maybe chemical or maybe any other things. There must be 2 electrodes like this. At the vicinity of the electrode, the EMF is same. When the reaction takes place, change in the EMF, that is going to give the information about an analyte. Accordingly, we are going to prevent some unwanted complications. As I have already discussed, amperometric sensor is one where we are going to measure the current directly or indirectly. This is called as 3 it is usually amperometric sensor is composed of 3 electrodes. One is called working, auxiliary, and reference electrode. Reference electrode is used to maintain constant potential. At the working electrode, the change in electrons because of oxidation reduction reaction takes place. Accordingly, it is going to give the input. Output is current. Input as an analyte where the reaction takes place will be converted into current. That signal is amplifying and giving it to the processor. Processor will identify the concentration and other species present in the substance. This is what it is called amperometric sensor, and where we are using bioelement, so it is called amperometric biosensor. So impedometric biosensor. An impedance biosensor measures change in electrical impedance when a biological molecule interact with a sensor at the surface. And these impedance changes help uh, to detect and quantify the specific biomolecules without needing any labels. This is what the electronic circuit, particularly in the impedometric method. So the change in the electric signal or resistance. We do plot a graph like capacitance versus resistance. This we do call it as real impedance and imaginary impedance. So definitely it works like this. So this is called it as impedometric biosensor. Voltammetric. The voltammetric is again the electrode system. And here also we are going to use a 3 electrode system, which is already interfaced with the computer. And we are going to use the bio element. So it is called it as voltammetric biosensor. By applying varying voltage and tracking how the current changes, it can detect and quantify the specific analyte with high sensitivity, particularly in the voltammetric biosensor. So, physical biosensor. So, the physical biosensor detects biological substance by measuring changes in physical properties like mass, temperature, light, or electric signal. So it works based on the principle that when a molecule interacts with a sensor surface, it causes measurable change in the physical parameter. That is, when it interacts, heat energy is released. Why? The reaction takes place. So during reaction, the change in the mass, or maybe sometimes light radiation is emitted. That is what it is called optical signal. Or sometimes during number of electrons are released, it is converting into electrical energy. So it is called as electrical property, which is then converted into a readable output. So this is what it is called physical biosensor. There are two types. One is called piezoelectric biosensor. We all understood what is piezo, that mechanical shock is converting into electrical energy. During polarization of the molecule, it is going to give some electron. Here there is no polarization, maybe molecule undergo oscillation. This oscillation leads to a pressure on the piezoelectric crystal that is going to give the electron. That electron is again depending upon the oscillation of this molecule, pressure exerted at the surface of this piezoelectric material. Based on this, it is going to convert into mechanical shock into electrical energy. That is the output, and where we are going to quantify the analyte concentration and other things. So the thermometric biosensor is one, the heat energy is exchanged. This is what they set up in piezoelectric biosensor. Piezoelectric biosensor detects biomolecule by measuring changes in the oscillation frequency of the piezoelectric crystal. So this is how it is made. There is a crystal, there is a material membrane, and there is template. We need to create before the template, and both on the piezoelectric crystal and the biomaterial and template will interact. When it is the molecule is comes and interact with this molecule may undergo oscillation, or maybe change in the heat, or change in the pressure, change in the mass, which will give the output is current. So based on this, one can easily understand what type of input is there in the system. They work on the piezoelectric effect where binding of biomolecule to the crystal surface changes its mass, causing a shift in the resonance frequency that is measured to determine the presence or amount of analyte present in the system. Okay. Any doubt here? Shall I proceed like this, or in the end I will ask the question? Okay.
Yeah, you can proceed. Okay. If there are any questions, then ask. But otherwise, you proceed. At the end, they will ask questions.
Sure, sir. Sure. So thermometric biosensor. A thermometric biosensor detects biomolecule by measuring the heat released or absorbed during biochemical reaction. It works on the principle when the enzyme catalyzed reaction produces measurable temperature changes. So this we do call it as in chemistry called enthalpy. Enthalpy means what? Heat content of the system. When any two molecules combine, there is a release of heat energy either in the form of absorption or in the form of release of heat energy. This we do call it as endothermic as well as exothermic. Exothermic heat energy is released. Usually, in most of the cases, when the natural reaction takes place and it is going to release heat energy. So, where we are going to measure the change in temperature. The change in temperature during the reaction will give the information about output information, that is nothing but concentration of biomolecules present in the analyte. This is together we do call it as thermometric biosensor. So optical biosensor. An optical biosensor detects biomolecule by measuring changes in light signal such as fluorescence, absorbance or refractive index. We all aware of it. During pandemic situation, they used one small device keeping in the finger like this, and it measures the oxygen level concentration in the blood. So based on that, they can detect on what basis. If lung is infected by that virus, uh, our lungs is unable to inhale more amount of oxygen, unable to transport the same oxygen to the blood. If that concentration is less than 96, some problem is there in the lungs. How do we know? By using this optical biosensor, the light radiation is passing both the end, and based on that, one can easily detect the amount of oxygen concentration in the blood. So based on that, one can easily identify the functioning of lung. So these are all called as optical biosensor. This optical biosensor permit a secure, non-electrical, inaccessible sensing of equipment. An extra benefit is that these frequently do not need reference sensor because the comparative signal can be produced by using the similar light source like the sampling sensor. So in this way, optical biosensor is having one of the important advantages to know one simple thing is the oxygen concentration in the blood sample. One can easily identify the lung capacity and other things just by using the small device in the hospital. So wearable biosensor. What are these wearable biosensor? So nowadays we all of us have one or the other kind of health complication, even though he may be young or maybe good old or maybe in between. Everybody is having one or the other kind of problem. Instead of going and staying in the hospitals, what we can do, we can wear all these sensor on the arm region, or maybe as a finger ring, or maybe in the chest region. By using all these things, it is connecting to the cloud, not exactly the computer. It is already connecting to the cloud, and every second, every minute, it is monitoring our health. What is the BP level? What is the glucose level, what is the heartbeat, now I am walking, whether it increases or remain, heartbeat is high or slow, so BP is increased or not, after taking food, whether it increase sugar level in the blood or not. All these things can be can be monitored at home itself, while walk, while doing work, all these things. And no need to stay in the hospital. We keep away from the hospital, and we can analyze ourselves by wearing these biosensors on the hand, maybe forearm or maybe in the chest region, anywhere. So that is giving continuous monitoring system and helping us directly, indirectly to maintain our health and perfectly fine in a day-to-day life. So this is what it is called, wearable biosensor. It calculates every time, every minute. Otherwise, we should be stay in the hospital nearly weeks together. That is costing and also wasting our valuable time. In this um, context, wearable biosensor plays a very important role in the present world. Anybody can use by taking that data. If we consult the doctor, he will give a prescribed medicine. So this is about wearable biosensors. So what are the characteristics of biosensor? First thing is the linearity. What is this linearity? Linearity means as increasing the analyte concentration, the output signal must be increased. It is directly related. If it is showing non-linearity, we cannot make the sensor. All materials cannot be used for the constructing sensor. Sensor is one, it must show The linearity means directly related as increasing the concentration. Some of the materials, as increasing the concentration, it increases. After some time, it becomes saturated. That is the limitation of that sensor. So this is what linearity. Sensitivity, this is very, very important. If the molecule comes and react like this, and it takes 5 minutes time, by that time something has happened in and around. Maybe accident may take place, maybe collapse, maybe catches fire, and it leads to a big complication. So immediately test to sense and give the signal and in a very quick response. This is what sensitivity. And selectivity, this is very, very important in making biosensor or any sensor. Selectivity means it has to select particular species and without having any other interference in the atmosphere. For example, we do have one cylinder. LPG is filled anyways. Liquid petroleum gas is odorless actually. That odor is giving, we mixed. Something is leakage and we should be able to understand there is leakage and we can avoid some accident later. So we mixed that odor gas in the LPG. Actually, it is odorless. So in this condition, we will fix a small electrode near the cylinder. That will sense immediately when this molecule will go and absorb change in the EMF. If it is respond to the oxygen present in the air or nitrogen or ammonia, some other molecule, it fails to detect exactly the LPG molecule. So selectivity plays a very important role in the construction. Even though by having all these interference, it has to identify only the particular species, not with any other ions or molecules present in the environment. So selectivity is very, very important. The last one, response time. This is very, very important. Quick response, we need immediate response. Otherwise, it delays and leads to some unwanted complications in the real time. At least the material must show the response time is 95% and above. It's very good sensor in real time. So these are the important characteristics of a biosensor. So now I will move to one simple one. I have taken this biosensor, particularly glucose sensor. Why I am using this? All of us are using one or the other way. Every day we are checking sugar level in the blood sample. What is the principle we used? How many generations? So many generations already done in the glucose sensor. And finally, we have wonderful sensor that is glucose oxidase molecule. This is also slightly, it is vanishing now because more engineers are there. There is more competition in doing research. And today technology, tomorrow won't be there. These are the fundamental principle in science. It remains same, but technologically it is different. So we are all using every day. That is what I am taking. This example is called biosensor, particularly glucose sensor. How it is constructed? One is components of glucose sensor and what is the working principle of glucose biosensor and what are the limitations. So let me discuss one by one. What is biosensor? Already we learned something. A biosensor is an analytical device which is used to determine the presence and concentration of a specific substance in a biological analyte. What is that specific analyte? Maybe in our urine sample, maybe the presence of sugar, maybe the presence of ketones, maybe some other molecules present in that. That is an analyte, biological analyte. So what we are going to use bioselective material. What are these bioselective materials? Maybe enzyme, maybe antibodies, maybe DNA, maybe organelle, maybe using microorganisms or animal cells can be used as bioselective material. And later, how we are going to detect this, that is called as biorecognition signal. If enzyme is there, it will go and react and there is a redox reaction. During redox reaction, what happened? Number of electrons are released, where we do measure electricity. So that electricity, it is required, maybe electrode system is required. There is change in pH, change in heat energy, change in light, change in the mass. We are going to use the transducer like electrodes, thermistor, piezoelectric materials, pH electrode, or maybe some other amperometrics. So other things will be used as a transducer. Already you know what is transducer. And the signal is so small that is converting, amplifying and processing the signal, and then we're giving the same thing to the computer. Computer is analyzed, and finally it is going to give the result. That is what analyte is, the input signal, and again that is converting into bioselective material where it undergoing reaction, maybe change in the mass, heat, light or electricity, that we are going to measure in the by using suitable material. It is nothing but transducer. It is called as sensor, and process data and final result, that is called it as output signal. So blood glucose monitoring, it is very much essential nowadays. You know why? Blood glucose monitoring is a way of checking the concentration of glucose in the blood using glucometer. It provides quick response to tell if the sugar is high or low, indicating change in diet or doing kind of exercise, or we can take some kind of medicine to reduce the sugar concentration in the blood. So based on this, one can use one or the other technique to reduce the concentration of sugar glucose level in the blood. It reveals individuals of blood glucose changes in an day-to-day life. Why monitoring of blood sugar or blood glucose is required? So because this usually the sugar is most dangerous one to the human beings. You know why? Other problems one can easily identify. So there is a joint pain. One can easily understand there is a pain in this area, and headache is there. At least I am going to sense I got headache, or fever is there. Body temperature is raised. But this sugar level is not like that. So it is already there in our body. It is always saying, I am with you. Be careful. In this condition, we are not aware of all these things. We are consuming carbohydrates and other things, not able to measure the concentration of glucose level in the blood all the times. That leads to it affects other organs like kidney, and if it affects kidney, again it affects liver, and again finally it goes to the heart. So because of all these unwanted risk due to the concentration of glucose in the blood. So every day we need, not every day, at least within 15 days, if the diabetic patient is there, within a week, he has to check thoroughly whether blood sugar level is controlled or not. Otherwise, it affects directly the vital organs in our body. So monitoring blood glucose is required nowadays. It reduces complication, particularly for the diabetic patients. Allows diabetic to see if the insulin and other medications they are taking whether it is working or not. They need to check thoroughly every day. For that reason, we have to use. Gives diabetics an idea as to how exercise and food affect their blood sugar, and they can plan. This is what it is called living practices. It is actually lifestyle disease. So everyone is having, because certain level our kidney is not able to function the way it function when we are at the young age. No, it slowly decreases the vital organ functioning. Automatically all these things will be there. This is what it is called lifestyle disease. And automatically we can understand all these things, and where we can maintain proper diet and other things. So it may prevent hypoglycemia or hyperglycemia. That is what we are seeing in the world. So type 1, type 2, all these things. But I don't want to elaborate in this reason, because how it works, I'm concentrating on this. Usually, we should know, each and every one of us know about this blood sugar level chart. Usually, if the person is normal, how do we take this 80 to 100 normally? So, out of curiosity, I want to explain this. Actually, we have selected 1,000 people of healthy people and taken their blood sample, measure the glucose level in the blood sample. So maybe somebody is having 80, somebody may be having 100, somebody may be having 150, somebody may be having 120. By taking averaging of all these things, an average is 80 to 100. It is called as fasting sugar. It is normal level. So this is what we have done the research in the present world. Based on this, we have fixed the normal sugar level range. Now it is 80 to 100. So fasting sugar level. Just ate, just to finish the breakfast, maybe lunch. Yeah, in that condition, if the sugar level is normal, at the time it raised to 170 to 200. After 3 hours, it should be 120 to 140 range. This is what it is normal. So don't be under the impression after 3 hours, if it is 140, oh, I am diabetic. Don't be under the impression directly. Don't come to any conclusion without having these reference values. And also, immediately we should consult the doctor. And pre-diabetic, always in the fasting, it is showing above 100, 100 to 125, maybe 140. All these things will be showing. This is clearly indicates pre-diabetic. Please take care of your health and take care of your food. You are not young, slowly you are aging, and your kidney is also not functioning properly. Not functioning properly means it has to release insulin. So that ability is slowly losing, and maintain all these things, exercise and taking proper diet and other things. So just ate. So immediately it raised 190, 230. Sometimes it may go to 300 also. So in that condition, maybe pre-diabetic condition. So after 3 hours, it is there 140, 160, 180. All this clearly indicates it is pre-diabetic symbol, and please take care of your body. And diabetic all the times in fasting sugar, it is showing above 130. Just ate, it goes to 300, 400. And after 3 hours also, it is maintaining above 200. Clearly indicates the patient is diabetic. So why I am explaining, by knowing all these facts, easy for you to understand the principle in the construction process. So by understanding all these things, what are the components are required to construct glucose sensor? One is called analyte, is the blood sample, or maybe any fluid sample is the analyte. The other one is bioreceptor. Bioreceptor is one, maybe enzyme. And transducer, it has to convert one form of energy into other. And electronics and display, and measuring the the concentration and other things need to calculate immediately on the small program is required in the glucometer and already written, and one small display. Through the display it will calculate, and directly it is displaying the amount of glucose present in the blood sample. These are the four components plays an important role in the construction of glucose sensor. It is called as glucometer. So now, what is the working principle? Actually, this glucose biosensor developed by Updike and Hicks et al. Have developed this. How they have developed? They use a glucose oxidase molecule, and this is an enzyme, and where the oxidation takes place. What is the oxidation? Glucose molecule undergoing oxidation reaction. During oxidation reaction, it is going to produce glucolacton and hydrogen peroxide. So in order to work as a catalyst, glucose oxidase requires redox, in order to work as a catalyst, glucose oxidase molecule requires redox cofactor. It is called as flavin adenine dinucleotide, FAD. Works as an initial electron acceptor, and it is reduced to FADH2 molecule. You take it, this is one of the best example I have indicated in the reaction. Glucose is reacting with glucose oxidase with a flavin adenine dinucleotide is the redox cofactor, which is going to react with this formation of glucolacton, and the reduced one, it is going to accept hydrogen from this, leads to the formation of glucose oxidase FADH2 molecule. So now, Sorry.
So continue, please continue.
Yeah, it's not moving.
Okay.
Yeah. Okay. This is the reaction takes place because I use that pointer, no, sir. That is what is not working. Yeah. So this is the reaction takes place between glucose and glucose oxidase and flavin adenine dinucleotide. It is acting as a redox cofactor and formation of this. And then, working of glucose biosensor, how it works. The cofactor is regenerated by reacting with oxygen, leading to the formation of hydrogen peroxide. This hydrogen peroxide is oxidized at the platinum electrode, is fixed in the glucometer. Actually, all of us are seeing that, strip. We are using a small strip and drop of blood sample we put on the strip. Actually, that strip is made up of 3 electrodes. Inside, a little amount of blood is going inside, and where this kind of reaction takes place. What is that reaction? So glucose oxidase FADS2. Initially it formed glucose oxidase FADS2, which is going to react with oxygen, and regeneration of glucose oxidase FAD molecule via the formation of H2O2. These already 3 electrodes are fixed in the strip, and it is going and connecting to the electronic circuit. So where the reaction takes place, actually that is H2O2. This H2O2 oxidized at the electrode is, and particularly the platinum metal is used, so it is called as platinum electrode. During the reaction, number of electrons are released. It is again depending upon how many glucose molecules present in the sample. So depending upon the glucose molecule, the number of electrons are released. This is going to give indirectly this much amount of the glucose molecule present in the blood sample. In this way, this system works. This system works. Any doubt in this? And this schematic representation clearly indicates there is a glucose reacting with glucose oxidase species with FAD, that is a redox cofactor, and leads to the formation of glucose oxidase FADS2 molecule via the formation of glucolactonate. And finally, this glucose oxidase FADS2 molecule is regenerated when it is reacting with water and formation of H2O2. This H2O2 will released at the platinum electrode, and where oxidation reaction takes place. During oxidation, number of electrons are released. The number of electrons is mainly depending upon number of glucose molecule present in the blood sample.
Hello.
Yeah.
Hello.
Sir, am I audible?
Yes. Yeah, you have a
Hi,
question. Yeah, you have a question.
Hello.
Kerry, what is it?
Yeah, I have a question.
Okay,
Yeah.
ask your question. Okay. And Kerry.
As you said it, the sensors only respond linear components, linear elements.
Yes, sir.
If any non-linear comes, then
But that non-linearity comes, that is one disadvantage, not giving accuracy. And that can be rectified.
So for that, something has to be. So there is a possibility also non-linearity is also some element may entering into that one.
Yes, sir.
And
Yes,
so
sir.
there is a possibility also there, no?
That non-linearity can be reduced by using some mathematical calculation, by using suitable models for the
I
non-linearity.
see.
But
Oh, I see.
if there is a linear one, no need to go for any modeling or any
Okay.
program is not required for that.
It is directly proportional to the both quantities.
Yes, sir. Yes, sir. Then it is acting as a very good sensor, not required to go for any modeling, any other modification is required. If there is a non-linearity, all these are required.
So you have mentioned two things.
Yeah.
One is atmospheric sensor, another is a biosensor. Is it not?
Yeah.
And
No,
then
no.
these sensor will respond to transducers.
Yes, sir.
Transducers, they convert the energy from one form to the other forms, and then analog systems.
Yes, sir.
Analog system then convert to the connected to the interfacing to the computer system, where it work as a brain.
Brain, correct.
And then the output result comes out. Is
Yes,
it not?
yes, sir. Yes, sir.
That's what I have understood. Thank
Yes,
you,
sir.
sir. Thank you
Sure,
very
sir.
much.
Okay, thank you.
Shall I
Okay.
proceed, sir?
You proceed. Yeah. Okay, proceed, please.
Yeah. See, we understood how the reaction takes place, how we made this glucose sensor. Actually, there is a membrane like this. So this membrane, the above one is a membrane, and in between enzyme is sandwiched, and below one is the electrode. In this condition, we to put a drop of blood sample on this membrane, will diffuse through this membrane to the enzyme, where the reaction takes place, and H2O2 is released, and this is moving to the electrode. After when it is moving towards the electrode, and it is undergoing oxidation reaction, and number of electrons are released, and finally we are going to measure indirectly the concentration of sugar molecule present in the blood sample. This is what the schematic representation shows. This is what the glucose glucometer is made. There are three layers. The first one is membrane, where we are going to put a drop of blood sample. It will go and diffuse through the enzyme, where the reaction takes place. During the reaction, glucose oxidase flavonine dinucleotide cofactor is produced, again which is reacting with oxygen, regeneration of this cofactor, and there is release of H2O2. This H2O2 again will be oxidized, number of electrons released. Finally, it is going to measure and quantify the system by using computer. This is what it is constructed in the glucometer. So what are the limitations? So limitation of this glucose sensor is extreme environmental condition like hematocrit values, or a modification of interference may potentially falsify the blood sugar blood glucose readings, and incorrect blood glucose readings may lead to treatment error, for example incorrect insulin doses. So all these things may happen in the hospital. So shall I reveal one case study here? One person, actually what happened, it is a real case study. One person had a jackfruit prior the consulting the doctor. The previous night, he had a jackfruit, nearly half kg. He was a diabetic patient. So immediately he went to the doctor, and doctor checked his blood sugar level. It is raised. It is showing more than 250. Whatever the medicine I am giving, it is not working. I have to change that medicine. So doctor changed the medicine, and the patient started taking new medicine. That, because of the jackfruit, he is not revealed. Doctor also not asked what you had in the previous night. He has not revealed anything. Both of us, doctor changed the medicine, and patient is also taken and taking 1 week together the same medicine. Within a month, it affects liver, and whatever the food is taking is not able to digest, and immediately they diagnose, and problem with the liver is not functioning because of this medicine. So after some time they have removed that liver transplant liver is changed, and after 1 year it is working fine, and immediately it affects and died. So my dear friends, I have one request with everyone. What happened in the previous night, what you had the food, you have to reveal all these things before consulting the at the time of consulting the doctor. Don't hide anything, because of this may be increased. Let me check 1 week with the same medicine, I will increase my exercise, or I will change my diet plan. In this condition, easy for us to avoid some health complication like this. And one more incident, he was my tenant here, and he has not discussed with anyone. He was identified as a diabetic. At age is nearly 35 to 36-year-old young man. He was having problem. He has consulted a doctor. Doctor told you are a diabetic patient. Then he is not taking any medicine. Thought that if I am doing gym and exercise, definitely it can be solve this problem. He thought. You know what he was doing? He was going to the gym, doing lot of exercise, coming back and having ragi mudde. You know, ragi mudde is high glycemic ratio than our rice. The diabetic patients, the ragi is not good for the diabetic patient. Those who are not diabetic, for them it is good. It is called it as a neutral millet. Ragi is called it as a neutral millet. And those who are non-diabetic, it is good. Diabetic patient, it is not at all acceptable. In this condition, he is going to the gym and coming home and having 3 or 4 ragi balls and taking enough rest. That is keep on increasing sugar level, and all of a sudden it affects on his heart, and sudden heart attack, collapsed and died. My dear friends, please, I am requesting you, don't be a self-medication like him, and you should consult the doctor, take a medicine and reduce sugar level in the blood sample. Automatically we can save our life, because you are the one important person in the world. Without you, can't see anything, can't listen. Without me, not able to talk, not able to take this session. So best friend is me, and in this world, I am the important person for myself. Maybe later stage, based on our knowledge and other things, we may help each other. Thank you very much for patient listening. This is about the limitation, and these are the instrumentation facility in our university. Thank you one and all for patient listening. Thank you, sir.
Thank you very much, Dr. Revanasiddappa.
Yes,
So
sir.
now there is some time for questions. If there are any questions, you may ask one by one, please. You may raise your hand digitally.
Shall I unshare, sir?
Yeah, you are. You please wait for the questions. The people will be asking questions. I have a question in continuation of what Professor Naik was saying.
Yes, sir.
ಈಗ ಲೀನಿಯಾರಿಟಿ ಯಾವ್ದಕ್ಕೆ ಬೇಕಾಗಿದೆ ಓನ್ಲಿ ಇಫ್ ಯು ಆರ್ ಡಿಟೆಕ್ಟ್ ಮಾಡ್ತಾ ಇರುವಾಗ ಲೀನಿಯಾರಿಟಿ ಇಸ್ ನಾಟ್ ಪರ್ಫೆಕ್ಟ್ಲಿ ಎಸೆನ್ಷಿಯಲ್ ಡಿಟೆಕ್ಟ್ ಓನ್ಲಿ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಮೆಜರ್ ಇಟ್ ದಟ್ ಆಲ್ಸೋ ಕ್ಯಾಲಿಬ್ರೇಟ್ ಮಾಡ್ಬೋದಲ್ಲ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲಿಬ್ರೇಟ್ ಯುವರ್ ಸೆನ್ಸರ್ಸ್ ನಾನ್ ಲೀನಿಯರ್ ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಆದ್ರೂ ಕೂಡ ಯೂಸ್ ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಚಾರ್ಟ್ ಅಂಡ್ ಫೈಂಡ್ ಔಟ್ ವಾಟ್ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ
Yes, sir.
ಲೀನಿಯಾರಿಟಿ ಇಸ್ ನಾಟ್ ದ ಮೋಸ್ಟ್ ಎಸೆನ್ಷಿಯಲ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಎ ಸೆನ್ಸರ್ ಅಂತ ನನಗನ್ಸುತ್ತೆ ವಾಟ್ ಯು ಥಿಂಕ್
No, sir, correct. What you are saying exactly right. But linearity is giving quick response. A non-linearity, it takes time, at least 10 seconds, 20 seconds, because I am also doing the humidity sensor application for my conducting polymer composites. And again, the recovery time is also important. So the response and recovery time, if it is delay and not able to sense immediately, that is what the problem. If there is a linearity and quick response will be there and easy to identify, and we can avoid some complications in the system, in the real-time monitoring system.
Okay. Other questions? ಮತ್ತೆ ಯಾವ್ದು ಪ್ರಶ್ನೆ ಇದೆ ಕೇಳ್ಬೋದು ಕನ್ನಡದಲ್ಲಿ ಕೇಳ್ಬೋದು ನೋ ಪ್ರಾಬ್ಲಮ್
Have you finished early, sir? Or
ಕೇಳಿ ಇಲ್ಲ ನೋ ರೈಟ್ ಟೈಮ್ ಯು ಆರ್ ಫಿನಿಶ್ಡ್ ಅಟ್ ದ ರೈಟ್ ಟೈಮ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ರೈಟ್ ಟೈಮ್ 50 minutes ಅಲ್ಲ ಯು ಫಿನಿಶ್ಡ್ ಅಟ್ 50 minutes ವಿ ವಿಲ್ ಹ್ಯಾವ್ ಲಾಟ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಪ್ರಶ್ನೆ ಉತ್ತರಗಳಿದೆ
yes, sir. ಕೇಳಿ.
ಈಗ ಸೆನ್ಸಿಟಿವಿಟಿ ಅಂತ ಹೇಳಿದ್ರೆ
Yes, sir.
ವಾಟ್ ಆರ್ ದ ಸೆನ್ಸಿಟಿವ್ ಲೆವೆಲ್ ನೀವು ಯಾವ್ದು ನಂಬರ್ಸ್ ಕೊಡಿಲ್ವಲ್ಲ ವಾಟ್ ಆರ್ ದ ಸೆನ್ಸಿಟಿವಿಟಿ ಲೆವೆಲ್ಸ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಡಿಟೆಕ್ಟ್ ವಾಟ್ ಸೆನ್ಸಿಟಿವಿಟಿ ನಂಬರ್ಸ್ ಏನು ಕೊಡ್ಲಿಲ್ಲ ಯು ಸೆಡ್ ದೇ ಸೆನ್ಸಿಟಿವ್ ವಾಟ್ ಆರ್ ದ ಲೆವೆಲ್ಸ್ ಕ್ಯಾನ್ ಯು ಗಿವ್ ಸಮ್ ನ್ಯೂಮರಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್
Yeah. Sensitivity means within 5 seconds it has to sense. When the analyte will come and attach with this sensor, it has to respond within 5 seconds. That is what highly sensitivity. If that sensitivity is not there, it is delaying the process, not able to respond immediately. For example, sir, see, we are using the mobile phone. This is a touch screen. When I touch through this finger, and this is what it is called capacitance conductor and ಹೇಳ್ತೀವಿ. So because that is insulator, the number of charges stored and on our fingertip also charge is there. When I touch, immediate response will be there. If it is delaying the process, sometimes it affects our operation. That is what sensitivity plays a very important role. Within 5 seconds, it has to sense.
So how are you going to improve the sensitivity of your biosensors? If you want to better and better quality sensors, you have any suggestions, sir? How to improve the sensitivity?
For improving the sensitivity, we have to use a pure molecule. So if there is impurity, definitely it can reduce the sensitivity. The other one, we do have some filters when we inject a blood sample into the strip. There is one small membrane is fixed that filters and sending the right kind of molecule to the electrodes.
Okay.
In that condition, we can improve the sensitivity, but it has to show initially, it has to detect there is something has happened, some reaction takes place. So then later we can improve all the sensitivity and other things.
ಸರ್ ರೇವಣಸಿದ್ದಪ್ಪ, ಈ ಮಿಲ್ಕ್ ಡೈರಿನಲ್ಲಿ ಯೂರಿಯಾ ಯೂಸ್ ಮಾಡ್ತಾರಂತ ಕೇಳಿದೀನಿ. ಏನಕ್ಕೆ ಅನ್ನೋದೇನಾದ್ರು ಹೇಳ್ತೀರಾ? ಯೂರಿಯಾ ಯೂಸ್ ಮಾಡ್ತಾರಂತ ಸರ್ ಮಿಲ್ಕ್ ಡೈರಿ. ಮಿಲ್ಕ್ ಏನಕ್ಕೋ ಗೊತ್ತಿಲ್ಲ, ಅದೇ ಕೇಳ್ತಾ
ಇದರಲ್ಲಿ ಕೆಲವರು ಪ್ರಿಜಿಡ್ಯೂಸ್ ಅಂದ್ರೆ ಯಾರಿಗೋ ತಿಳಿಲಾರದರು ಯೂರಿಯಾ ಮಿಕ್ಸ್ ಮಾಡ್ಬಿಡ್ತಾರೆ ಅಂತ. ಹಂಗೆ ಯೂರಿಯಾ ನಾವು ದಿನ ಹಾಲಲ್ಲಿ ಕುಡಿದಿದ್ರೆ ಇಷ್ಟೊತ್ತಿಗೆ ನಮಗೆ ಬ್ಲೂ ಬೇಬಿ ಸಿಂಡ್ರೋಮ್ ಬಂದ್ಬಿಡೋದು. ಅದು ಏನೋ ಒಂದು ಜನ ಸುಮ್ನೆ ಕಲ್ಪನೆ ಮಾಡ್ತಾರೆ.
ಹೌದಾ?
ಹೌದು, ಅದು ಬೇರೆ ಇಂಗ್ರೀಡಿಯೆಂಟ್ಸ್ ಹಾಕಿ ಏನೋ ಮಿಕ್ಸ್ ಮಾಡ್ಬೋದು, ಬಟ್ ನಾಟ್ ಡೈರೆಕ್ಟ್ಲಿ ಯೂರಿಯಾ. ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಸರ್, ಯೂರಿಯಾ ಡೈರೆಕ್ಟ್ಲಿ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ಕನ್ಸ್ಯೂಮ್. ಇಫ್ ಯು ಕನ್ಸ್ಯೂಮ್ ಯು ಆರ್ ನಾಟ್.
ಅದಕ್ಕೆ ಕೇಳಿದೆ, ಯಾಕಂದ್ರೆ ಯೂರಿಯಾ ಯೂಸ್ ಮಾಡ್ತಾರೆ.
ಇಲ್ಲ, ಅದು ಇಟ್ ಇಸ್ ಅ ನೈಟ್ರೋಜನ್ ಫರ್ಟಿಲೈಸರ್.
ಅಮೋನಿಯಾ ತರ ಎಲ್ಲ ಜಾಸ್ತಿ ಇರುತ್ತೆ.
ಅಮೋನಿಯಾ. If we take directly that, it affects our kidney, liver immediately. Not possible to survive. We are all surviving, no sir, without having any complications. So many years we are drinking the same.
Okay. Any other questions? ನಾನು ಇನ್ನೊಂದು ಕೇಳಿದ್ದೀನಿ, ನಾನು ಎಷ್ಟು ಮಟ್ಟಿಗೆ ನಿಜಾನ ಗೊತ್ತಿಲ್ಲ. Without actually taking the blood sample, we can detect the blood glucose level ಅಂತ ಕೇಳಿದ್ದೀನಿ. Is that possible?
Yes sir, it is possible through the sweat and by using the wearable sensors.
ಅದ್ಯಾವ್ದು?
Wearable sensor ಅಂದ್ರೆ our own college students have developed sir. ಈ ಫಿಂಗರಿಂಗ್ ಹಾಕೊಂಡಿದ್ರಲ್ಲ, ಇದೇ ತರ ರಿಂಗ್ ಹಾಕೊಂಡ್ಬಿಟ್ರೆ it is connecting to the cloud. ನಾವು ಎವ್ರಿ ಡೇ ನಾವು ಊಟ ಮಾಡಿದಾಗ ಎಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿ ಎಷ್ಟು ಶುಗರ್ ಲೆವೆಲ್ ಆಯ್ತು, BP ಎಷ್ಟಾಯ್ತು, ಹಾರ್ಟ್ ಬೀಟ್ ಎಷ್ಟಾಯ್ತು ಎಲ್ಲ ರೆಕಾರ್ಡ್ ಮಾಡುತ್ತೆ. In the end of the day, we can download that and we can take that printout and consulting the doctor, he will suggest.
I see.
Yeah, through this. That is
painless technique, painless, without pain.
ಆಮೇಲೆ ಡಯಾಬಿಟಿಕ್ ಇದ್ದವರು ಎಸ್ಪೆಷಲಿ ವೈಟ್ ಪಾಟ್ ಅಂದ್ರೆ ಮಿಲ್ಕ್ ಆಗ್ಲಿ, ಕರ್ಡ್ ಆಗ್ಲಿ, ರೈಸ್ ಆಗ್ಲಿ ತಗೋಬಾರ್ದು ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾರೋ ಒಬ್ಬರು ಡಾಕ್ಟ್ರು ನೈಟ್ ಟೈಮ್ ಒಂದು ಕಪ್ ಮೊಸರು ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳಿದ್ರು. ಏನು ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ಹೇಳ್ತಾರಲ್ಲ, ನಿಮ್ಮ ಸಜೆಷನ್ ಏನು?
I will answer for Nagaraj sir. Shall I?
Please answer.
Sir, those who are diabetic, try to avoid the consumption of milk. Milk is not acceptable. And consuming curd in the night is not advisable for the male like us. Because ನಮ್ಮ ಪುರಾಣಗಳಲ್ಲೇ ಒಂದು ಕಥೆ ಇದೆ ಸರ್. ಒಬ್ಬ ರಾಜ ಇರ್ತಾನೆ, ಆ ರಾಜ ಫುಲ್ ಆರೋಗ್ಯವಾಗಿರ್ತಾನೆ. ಆ ರಾಜನ ಆಸ್ಥಾನದಲ್ಲಿ ಒಬ್ಬ ರಾಜ ವೈದ್ಯ ಇರ್ತಾನೆ. ಅವನ ಹೆಂಡತಿಗೆ ಕೊರಳಲ್ಲಿ ಬಂಗಾರದ ಹಾರ ಮಾಡ್ಕೊಳ್ಬೇಕಂತ ಆಸೆ ಆಗ್ಬಿಡುತ್ತೆ. ಡಾಕ್ಟರ್ ಹೆಂಡತಿ ವೈದ್ಯನಿಗೆ ಹೇಳ್ತಾನೆ, ನೀನ್ ರಾಜ ವೈದ್ಯನಾಗಿ ನನಗೆ ಒಂದು ಬಂಗಾರದ್ದು ಮಾಡಕ್ ಆಗ್ತಾ ಇಲ್ಲಲ್ಲ, ಏನ್ ಮಾಡ್ಬೇಕು ಅಂತ. ಹಾಗಾದ್ರೆ ನೀನು ಡಾಕ್ಟರ್ನ ರಾಜನ ಅನಾರೋಗ್ಯನಾಗಿ ಮಾಡ್ಬೇಕು ನೀನು ಅಂತ ಹೆಂಡತಿ ಕೇಳ್ಕೊಂತಾನೆ. ಅದಕ್ಕೆ ಅವನು ರಾಜ ವೈದ್ಯ ಹೆಂಡತಿಗೆ ಹೇಳ್ತಾನೆ, ನೀನು ಒಂದು 15 ದಿನ ಆ ರಾಜ ಏನೇನು ಊಟ ಮಾಡ್ತಾನೆ ಅಬ್ಸರ್ವ್ ಮಾಡು ಅಂತ ಹೇಳ್ತಾನೆ. ಆಯ್ತು, ಅವನು ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡ್ತಾಳೆ. ಈಗ ರಾತ್ರಿ ರೈಸ್ ಹಾಕಿದ್ರು, ಆಮೇಲೆ ಮೊಸರು ಹಾಕ್ತಾ ಇದ್ದಾರೆ, ಅವನ ಆರೋಗ್ಯ ಹೋಯ್ತು ಅಂತಾನೆ. ಆಮೇಲೆ ನಮ್ಮಲ್ಲಿ ಒಂದು ನಿಂಬೆಕಾಯಿ ದೊಡ್ಡದು ಬರುತ್ತೆ ಸರ್, ಅದು ಹೆಸರು ನನಗೆ ನೆನಪಾಗ್ತಾ ಇಲ್ಲ.
ದಡ್ಲಿಕಾಯಿ
ಆ ಉಪ್ಪಿನಕಾಯಿ ತಿಂತಾರೆ, ಅಂದ್ರೆ ಅವನ ಆರೋಗ್ಯ ಇಂಪ್ರೂವ್ ಆಯ್ತು, ನೋ ಪ್ರಾಬ್ಲಮ್ ಅಂತ. ಸೊ ಯೂಶುವಲಿ ಗಂಡ್ ಮಕ್ಕಳಾದರೂ ರಾತ್ರಿ ಮೊಸರು ತಿನ್ಬಾರ್ದು, ನಮ್ಮ ಏನ್ಷಿಯಂಟ್ ಡೇಸ್ ಇಂದನೂ ಇದೆ.
ಬಿಟ್ಬಿಡಿ, ಈಗ ಡಾಕ್ಟರ್ಸ್ ಏನ್ ಹೇಳ್ತಾರೆ ಮುಖ್ಯ ಅಲ್ವಾ? ಈ ಪುರಾಣದ ಬಗ್ಗೆ ನಾವು ನಂಬಿಕೆ ಇಟ್ಕೊಳಕ್ ಆಗಲ್ಲ. ಡಾಕ್ಟರ್ಸ್ ಏನ್ ಹೇಳ್ತಾರೆ ಅಂತ, ಡಾಕ್ಟರ್ಸ್ ಹೇಳೋದಲ್ಲ. ಪ್ರೋಟೀನ್, ಮಿಲ್ಕ್ ಇದೆ ಗುಡ್ ಸೋರ್ಸ್ ಆಫ್ ಪ್ರೋಟೀನ್, ತಗೊಳ್ಳಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಓನ್ಲಿ ಕ್ಯಾಲೋರಿ ಶುಡ್ ಬಿ ಕಂಟ್ರೋಲ್ಡ್ ಫಾರ್ ಶುಗರ್ ಕಂಟ್ರೋಲ್ ಅಂತ.
ಸರ್ ಇದು ನೀವ್ ಹೇಳಿದ್ರಲ್ಲ ಸರ್, ಇದು ಬಹಳ ಕರೆಕ್ಟ್. ಇದು ಪುರಾಣಗಳಲ್ಲಿದೆ, ನಾವು ನಂಬಕ್ಕಾಗಲ್ಲ, ವಿ ಆರ್ ನಾಟ್ ಪ್ರೂವಿಂಗ್ ಸೈನ್ಸ್ ಅಂತ. ಬಟ್ ಆಕ್ಚುಲಿ ಸ್ಪೀಕಿಂಗ್, milk and curd is not advisable in the night. In place of curd and milk, we should take buttermilk.
Okay.
Because which is having very good microorganism. It helps to improve our gut health.
Okay.
This is what the scientific reason.
Next question.
Sorry,
ಇವಾಗ
sir.
ನೀವು ಸ್ಪೆಸಿಫಿಸಿಟಿ ಬಗ್ಗೆ ನೀವು ಜಾಸ್ತಿ ಮಾತಾಡಿಲ್ಲ. ಡಯಾಬಿಟಿಸ್ ಇಸ್ okay, it's a well studied thing.
Yeah.
But there could be trace metals, and then sometimes you may have to detect it very fast within milliseconds. In that case, is specificity ಆಮೇಲೆ ದಿ ಸೆನ್ಸಾರ್ ಮೆಟೀರಿಯಲ್ಸ್ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡಬೇಕಾಗುತ್ತೆ.
Next time ಮಾಡೋಣ ಸರ್.
ಓಕೆ, ನಿಮ್ಮ ಯಾಕೆಂತಂದ್ರೆ ಸ್ಪೆಸಿಫಿಸಿಟಿ, ಸೇಮ್ ಥಿಂಗ್ ಯು ನೋ, ದಿ ಅದರ್ usually you have a mixture of things. It's not just a single thing.
Correct.
Therefore ಬೇರೆದು ಕೂಡ ನಿಮಗೆ ಅದೇ ಸಿಗ್ನಲ್ ಕೊಟ್ಬಿಡುತ್ತೆ, ಅದು ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಅದನ್ನ ಯಾವ ತರಹ ನೀವು ಡಿಸ್ಕ್ರಿಮಿನೇಟ್ ಮಾಡ್ತೀರಾ, ಇದೆಲ್ಲ ಇಂಪಾರ್ಟೆಂಟ್ ಇಶ್ಯೂಸ್ ಅದರಲ್ಲಿ.
Eliminated by using suitable chemical reactions, sir.
It becomes more and more complicated, and finally
more complicated.
you know, the ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಅದು ಎರರ್ಸ್ ಹೇಗೆ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. ಆಮೇಲೆ ಸಮ್ಟೈಮ್ಸ್ ಯು ಮೇ ಹ್ಯಾವ್ ಟು ಡೂ ಇಟ್ ಇನ್ ಮಿಲಿ ಸೆಕೆಂಡ್ಸ್, ಲೈಕ್ ಕಾರ್ಬನ್ ಮಾನಾಕ್ಸೈಡ್. ವಿತ್ ಇನ್ ಸೆಕೆಂಡ್ ಮೇ ಬಿ ಟೂ ಲಾರ್ಜ್ ಫಾರ್ ಸಮ್ ಆಫ್ ದ ಥಿಂಗ್ಸ್. ಸೊ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ, ವೆರಿ ಕ್ವಿಕ್ ರೆಸ್ಪಾನ್ಸ್ ಟೈಮ್ ಶುಡ್ ಬಿ ವೆರಿ ಲೋ ಅಂದಾಗ ಏನ್ ಮಾಡ್ತಾರೆ.
ಸೊ ಅವಾಗ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಸರ್, ಆ ಮಾಲಿಕ್ಯೂಲ್ ನ ಆಕ್ಟಿವೇಟ್ ಮಾಡ್ತಾರೆ ಬೈ ಫಿಕ್ಸಿಂಗ್ ಸ್ಮಾಲ್ ಕಾಯಿಲ್. And they are elevating to 50 to 60 or 100 degrees Celsius. In that condition, that molecule is active and it can sense immediately.
Okay, but heating up is a slow process.
That is what, already it is preheated and it is connected the power in the form of the battery and other things. It is not required the large amount of heat to heat up the coil. It takes within 1 minute.
Okay, fine.
Because that sensor is so small and so thin, immediately it raises the temperature.
Other stability alla hage over course of time.
It is optimized by using right kind of the controlling tools, temperature controllers.
Okay.
Yeah, will be there.
Thank you.
Right. Okay, thank you very much. So if there are no further questions, I request our General Secretary, Professor Nagaraj, to propose a vote of thanks.
Thank you very much, sir. Revanasiddappa, ಸಾಕಷ್ಟು ಹೆಲ್ತ್ ಟಿಪ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀರಾ. ಬಯೋಸೆನ್ಸಾರ್ಸ್, ವೆರೈಟಿ ಆಫ್ ಬಯೋಸೆನ್ಸಾರ್ಸ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೀರಾ. ಫೀಸೋ ಎಲೆಕ್ಟ್ರಿಕ್, ಥರ್ಮೋ, ಹಾಗೆ ಸುಮಾರಷ್ಟು, ಯಾಕೆಂದ್ರೆ ಒಂದಲ್ಲ ಎರಡಲ್ಲ ಹೆಲ್ತ್ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ಸೆನ್ಸಾರ್ಸ್ ಏನಿದೆ ಎಲ್ಲನೂ ಕೂಡ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಾ. ಸೊ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ಆಮೇಲೆ ಇನ್ನೂ ಒಂದು ಹೇಳಿದಿರಿ, ಯಾಕೆಂದ್ರೆ ಇನ್ನ ಒಂದು ಟಾಕ್ ಕೊಡೋದಕ್ಕೆ ರೆಡಿ ಇದ್ದೀನಿ ಅನ್ನೋ ಮಟ್ಟಿಗೆ ಹೇಳಿದೀರಾ. ಸೊ ಅದಕ್ಕೆ ಅವಕಾಶ ಸಿಕ್ಕಿದಾಗ ತಮ್ಗೆ ಇನ್ನೊಂದ್ಸಾರಿ ಪ್ರೊಫೆಸರ್ ಕಾಗ್ಲಿ ಅವರು ಇನ್ವೈಟ್ ಮಾಡ್ತಾರೆ. ಎನಿವೆ, ನಿಮ್ಮ ಎಂಥೂಸಿಯಾಸಮ್ ಮತ್ತೆ ಇದ್ರ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ತಿಳ್ಕೊಂಡಿರೋದಕ್ಕೆ ನಿಮ್ಗೆ ತುಂಬಾ ಧನ್ಯವಾದಗಳು. ಹಾಗೇನೆ ನಮ್ಮ ಈ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಅಂದ್ರೆ ಝೂಮ್ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ನ ಪ್ರತಿ ಆಲ್ಮೋಸ್ಟ್ ಸಂಡೇ ಕೊಡ್ತಾ ಇರುವಂತ ಡಾಕ್ಟರ್ MK ರಾಘವೇಂದ್ರ ಜ್ಞಾನಧಾರ ಅವರುಗಳಿಗೆ ಧನ್ಯವಾದಗಳು. ಮತ್ತೆ ಕಾಗ್ಲಿ ಅವರಿಗೆ ಅರೇಂಜ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. SV ವೆಂಕಟರಾಮನ್ ಅವರು ಕೂಡ ಯೂಟ್ಯೂಬ್ ನಲ್ಲಿ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ಅವ್ರಿಗೆ, ಮತ್ತೆ ನಮ್ಮ ಎಲ್ಲ KPM ಮೆಂಬರ್ಸ್ಗಳಿಗೂ ಧನ್ಯವಾದಗಳು. ಮತ್ತೆ ಯಾರೋ ಕೆಲವು ಗೆಸ್ಟ್ ಕೂಡ ಬಂದಿದ್ದಾರೆ ಅಂತ ಕಾಣಿಸುತ್ತೆ. ಎಲ್ಲ ಗೆಸ್ಟ್ಗಳಿಗೆ, ನಮ್ಮ KPA ಮೆಂಬರ್ಸ್ಗೆ ಮತ್ತೆ ಇನ್ನೊಂದ್ಸಾರಿ ತಮಗೆ ಧನ್ಯವಾದಗಳನ್ನ ಅರ್ಪಿಸ್ತಾ ನಮ್ಮ KPA ಕಾರ್ಯಕ್ರಮ ಹೀಗೆ ನಡೀತಾ ಇರಲಿ ಅಂತ ಹೇಳಿ ಪ್ರೊಫೆಸರ್ ಕಾಗ್ಲಿ ಅವರು ಏನಾದ್ರೂ ಅನೌನ್ಸ್ಮೆಂಟ್ ಕೊಡೋದಿದ್ರೆ ಅವ್ರ ಕಡೆಗೆ ಹೇಳ್ತೀನಿ. Thank you, sir. Thank you, one and all.
Let me thank Dr. Revanasiddappa M. Very highly interdisciplinary subject. Biology ಇದೆ, chemistry ಇದೆ, physics ಇದೆ, ಎಲ್ಲ ಇದೆ, medicine ಇದೆ. Very highly interdisciplinary subject. ಈ ತರದ್ದು very useful subjects ಅಂತ ಈಗೆಲ್ಲ ಎಲ್ಲ ಕಡೆ encouragement ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Very nice that he has given us a talk. So thanks to you again. I thank all the members for participating. Next week also we'll be having a talk at the same time. Please join us. Next week I think it will be a talk by Dr. Shair.